Alright, yesterday we learned that if you were multiplying a binomial times a binomial, what method do we use? Full. And full is an acronym for what? First, outer, inner, last. And that's how we multiply, and that's how it's really just doing the distributive property with each term of this binomial. You're multiplying those two and then those two together. So let's look at it. These two binomials are what I'm calling a special case. They are called conjugates. It is important that you remember that word, so please write it down. Conjugates are two binomials that are exactly the same except for their middle signs. So x plus 6 and x minus 6 are conjugates. And you might say, well, why do I need to know what their name is? It's because in the end of the chapter, when we're factoring, the answer that we get down here, the difference of two squares, you're going to have to be able to recognize is a difference of two squares, and you're going to have to remember from today that the answer to it will be conjugates. So what we're going to be doing in the second part of the chapter is the very reverse of what we're doing today. Today we're multiplying, and then when we get to the end of the chapter, we're just going to factor. Okay, so I'll show you in just a minute what I mean by what the difference of two squares is. Alright, so let's full. I can use the full method because I have two binomials. By the way, if you had to classify these by degree, what kind of binomial is this? Linear. And the same thing here, right? Alright, so x times x is?
X squared.
X squared. That's first. Outer. 6 times x is?
6x.
6x. Inner, negative 6 times x is negative 6x. And last, negative 6 times 6 is negative 36. Now yesterday, that's what we did. And then we would combine those like terms, and that would be our answer. First, outer, inner, last, when you're multiplying two binomials. But with the conjugates, their special case, if you will notice, outer and inner are going to cancel each other out. Why? Because they are opposites. And they always will be, because with conjugates, you always have your different signs. Does that make sense? So when you do outer and inner, one of them will be negative and one of them will be positive. So they'll cancel out. That just happens with conjugates. And the answer you get is what's left. And I have x squared and a negative 36 left. Now this answer is called the difference of two squares. Let's label that. We labeled the problem conjugates. We're labeling the answer the difference of two squares. Now let me show you how simple it is to know why you call this the difference of two squares. First of all, what's this sign?
Negative.
Minus, negative, okay? Thus the word difference. We're always going to have a negative sign right here. Okay? Difference. Is this a perfect square? X squared. Is that a perfect square? Yeah. Is 36 a perfect square? Yes, it's 6 times 6, isn't it? So we call this the difference of two squares, because that's exactly what it is. There's a minus sign in between. That's the difference of two squares. Now in Algebra 2, we just call this dots. Difference of two squares. That helps them to remember, okay? Now, when is the only time I will get the difference of two squares? When I'm multiplying, what are these called?
Conjugates.
Conjugates. I know that's a weird sounding word. But does at least this name make sense?
Yeah.
Because it's the difference of two squares? Okay. Does this qualify as conjugates? Is everything exactly the same except for their middle signs?
Yes.
Yes.
I've got a 3x minus 4 and a 3x plus 4. So I am looking for my answer to give me the difference of two squares. Finished?
Got a question?
Okay. Okay, so let's see how you did. First, outer, inner, last. Did you notice these were opposites? Now, I have people that would mark out a 12x and a 12x. Why am I marking these out? Because one of them is positive and the other one is negative. That's why they cancel each other out. I got asked this question, I guess today in Algebra 2 maybe, I can't remember exactly. They said, it was Algebra 1, what is 2x squared minus 2x squared? They said, is it just x squared? Or is it nothing? Well, if I have two pencils, and I subtract two pencils, do I have just pencil left? That sounds funny, doesn't it? But the same thing applies. So what's 2x squared minus 2x squared? 0. What's 12x minus 12x? 0. There's not an x left. And so, does this qualify as the difference of two squares?
Yes.
Difference, perfect square, perfect square, perfect square. Agreed?
Yes.
Now, will they always be perfect squares?
When these are conjugates.
Okay.
Yesterday, we didn't work any conjugates. That's what you missed. Yesterday, these weren't conjugates, and so the outer and inner would just combine like terms, and we would have a trinomial. Today, we just got a binomial. All right, another special case we need to write down is this one, the binomial squared. The binomial squared. Now its name makes great sense. It is a binomial.
And it's squared.
It is squared. Binomial squared, right? Now, here's what people do. And I would say this is one of the most commonly missed problems. I don't care if they're in Algebra 2, if they're in pre-cal or whatever. They'll say, oh, the answer to that must be 2x times 2x, 4x squared, let's see, negative 3 times negative 3 plus 9. But that's not right. What does squaring something tell you to do? Multiply something by itself. And so I will have 2x minus 3 times 2x minus 3. And since those are both binomials, what method do I use? Well, since we're down to one method, that's the only thing we've done, right, is the full method. We'll full this. Because the only time you use the full method is when you're multiplying two binomials, and that is exactly what we're doing. So first, outer, inner, last. So far, so good? Question. Do outer and inner cancel? Since they have the same
No.
sign, they do not. Okay. That's how this is different from conjugates. Okay, my answer will then be 4x squared minus, put those together, 12x plus 9. And you call this a perfect square trinomial. There are 3 tests that we will use later in the chapter to determine that this is a perfect square trinomial. Now, remember, it's already made sense to us why we call this a binomial square, okay? So there's 3 tests, and let me make sure that you understand what they are. First test and second test are pretty easy. They say, the first test says, is this a positive perfect square? 4 is a perfect square, x squared is a perfect square, it's positive, so yes. Agreed? Is the last term, that's the second test, is the last term a positive perfect square?
Yes.
Yes. Okay, here's the third question. It's a little more, bit more involved, okay? What do you square to get 4x squared?
2x.
2x. What do you square to get 9?
Or negative 3.
What is their product? 6x. Doubled 12x. That's the middle. Now the first two questions were easy. Okay? Is this a positive perfect square? Is this a positive perfect square? Alright, then you gotta get involved. What do you square to get this? What do you square to get this? And what is their product doubled? Should be this. Why am I doubling it? Because look right up here, weren't there 2 of them? Okay, so we call this a PST. Perfect square trinomial. I like to shorten things in Algebra 2 as much as we can because it's so much to learn. Alright, so this was we've gotten 2 special cases. This was a binomial squared. It gave us a perfect square trinomial. Earlier we learned conjugates and they gave us dots. What's dots?
The
Difference of 2 squares, right? That's all we've learned so far today. Okay, let's learn this. Let's look at this one. On every problem we've worked so far, outer and inner, on every one of them, yesterday and today, outer and inner were always what? Like terms. This, I told you most of them would be, but this is the case where it's not, and let me show you how I know that. Let's classify this binomial. Since it's got a square, what do you call that?
Quadratic.
Quadratic. Let's classify this binomial
Linear.
linear to the first power, right here. Since they have different degrees, when I do outer and inner, you will see that we will not get like terms. We will not have outer and inner combining in this problem. All right, let me show you one. All right, I have 2 binomials, so that's why I can use the full method. What do you think 2x squared times x is?
2x cubed.
Yes. Remember when we multiply the bases, we add the exponents. So 2 and 1 is 3. Okay, outer would give
8x squared.
8x squared. Inner, negative 3x. Last,
12.
yes, negative 12. Alright, do you guys see any of those that we can combine for like terms? Neither. How would we classify this polynomial? It's a degree of 3, cubic polynomial with 4 terms. That's all we can say. That's my answer. That's as far as I can go. Okay, so to review from yesterday. Practice that. Am I going to use the full method? That's a trick question. Why not?
It's not 2.
That's a monomial, isn't it? It's not a binomial. Okay, so then what property am I using?
It should be
What is 3x times x?
3x
3x
squared.
squared.
What is 3x times negative 4?
Negative 12x.
Is this in descending order,
Yes.
standard form? Okay. The other type we did yesterday, they were not conjugates. they were not the difference of two squares. They were just two binomials. So when you multiply two binomials, let me say that again. If y'all watch this video, you're gonna be like, oh, boy, she said that 12 times. I mean, a bunch of times. All right, so what method do we use when we multiply two binomials?
Foil.
FOIL. So, first, are you guys drawing the lines or leaving them off? You can do either one you want to. Outer. Inner. I'm gonna confuse somebody if I leave that. Inner is here. And then last. There we go. Now, these were of the same degree. They were both linear. And so we were going to find that these are like terms. So 6x squared and then what? Then what? What do you get if you put these together?
Plus 7x.
Plus 7x and minus 20. Classify this. Quadratic.
Polynomial 3 times.
What do you call it? What do you call it? Trinomial.
Trinomial.
Good. Alright, copy this down, and that is your assignment.